The next cross-sectional element is cross slope or camber. The main objective of providing camber is to provide the drainage facility on top surface of the pavement. Not only this camber is provided for the top layer, but it is provided from the subgrade level itself. How exactly this cross-sectional slope or transverse slope help in diverting the water? The moment storm water reaches the pavement surface, that slope diverts the water and it makes the water to reach the nearest side drain, and then it can maintain the pavement surface comparatively in dry condition. And just if I go through some of the important key reasons to prevent the entry of surface water into the pavement layers and the subgrade soil through pavements, and to prevent the entry of water into the bitumen pavement layers, as continued contact with water causes stripping, and there are many problems or defects that you can observe when water comes in contact with bitumen. And to remove the rainwater from the pavement surface as quickly as possible and to allow the pavement to get dry soon. Just as I told you, all these functions are 100% related to the drainage facility, and that too when it comes to the stormwater condition. How exactly this cross-sectional slope is provided? So, it can be provided in many ways. In some percentages, or we can also call it in terms of 1 in n. So where for one vertical n horizontal, we can define that cross-sectional slope in this fashion also. The required camber of a pavement depends upon the type of the pavement surface and amount of rainfall. How exactly we can design the camber? Indian Road Congress recommends the design or the determination, or we can select the camber. There are two different parameters which helps us in identifying that. Those two parameters are type of pavement surface and type of rainfall condition. So if you observe, this is the table given by Indian Road Congress for selecting the camber percentages. So if you are going for cement concrete or height type bituminous pavement surface, and if the project area is under heavy rainfall condition, then the camber will be of 2%. If it is a low rainfall area, you can reduce this up to 1.7% also. But when it comes to the thin bituminous surface, the minimum value of this camber is 2.5% in heavy rainfall conditions, and it is up to 2% in low rainfall conditions. When for waterborne macadam or gravel pavements, it is 3% in heavy rainfall condition, and it is 2.5% in low rainfall condition. But in earthen road, the percentage once again is more. It's 4% in heavy rainfall condition and 3% in low rainfall conditions. If you just observe the percentage of camber from cement to earthen road, it is continuously increasing. If you just observe the porosity of this type of materials or that type of layer, cement concrete is 100% dense, and height type of bituminous surface is also 100% dense, and both the layers are almost impermeable. Hence they will not allow water to percolate into it, and hence it can easily divert the water, and 2% of slope is more than enough to divert that water, because that type of layer is impermeable. When it comes to thin bituminous surface, it is slightly permeable, and if that percentage of slope is less than 2.5, then it may some situation allow some percentage of water when it comes to heavy rainfall condition area. So hence 2.5 is the minimum, and into low rainfall it is 2%. And waterborne macadam is more porous than the thin bituminous surface. Once again, the percentage of camber is more than thin bituminous surface. In the same way, earthen road 100%, it is having maximum pores in it, and it needs a heavy slope to divert the rainwater without percolation. That is 4%. And in the same way, in low rainfall condition also, the percentage are increasing from 1.7 to 3%. 3%. All these are the different recommendation values by Indian Road Congress. Now, how exactly, in what way they can be constructed on site? What are the different shape of this cross slope? It can be parabolic, it can be straight, or it can be the combination of both straight and parabolic. In the first figure A, you can see the complete camber is provided in both the direction by providing maximum value at the center of the highway section. Maximum camber is provided, and slowly that slope, cross-sectional slope, is provided to the edges. So that is in a parabolic fashion. That equation for this type of camber or parabolic curve is y is equals to 2x square divided by nw, where 2x square divided by nw, where w is the width of pavement, n is the slope, and x is the horizontal distance at any point of section. And the second type of cross-sectional slope is straight line camber. It is one of the simplest type of providing the camber facility. Maximum camber value at the center and 0 at the edges. So when it comes to the straight camber, the functioning of this type of camber on site will be little bit difficult, or it may end with some discomfort in the road users. But anyhow, the equation of this is very simple. It is just a slope, direct to slope. You can fix 1 in n and height will be w by 2n. So by then you can calculate the camber value easily. And the third one is the combination of both straight and parabolic. You can see at the edges, when it tends to move towards the center of the pavement section, they are straight, and central part is provided with a parabolic curve. This will work definitely well compared to both the type of other type of providing camber facilities. So these are the different type of camber facilities that you can observe, by which we can construct it on site, and they may work well. Then the next cross-sectional element is the width of pavement or carriageway. You might have seen different types of width, and especially in village sections you can observe single lane highways. When it comes to the other district road and major district roads, you may go for seeing intermediate sections. It means just the width of carriageway is more than single lane, but you may not feel that as a double lane. And definitely that double lane will be different, and their width are more than intermediate lanes. And obviously you might have seen multi lanes also. What are the different standards given by Indian Road Congress for this type of width of carriageway? If it is a single lane, then 3.75 meter is the carriageway width, and if it is a 2 lane without raised curbs, like adjacent curves, then 7 meters. If 2 lane, if there are without any type of curbs, then 7 meters. If with curbs, to provide some psychological comfort to the passengers, 0.5 meter has been increased, that's why it is 7.5 meters. And intermediate lane, as I told you, it is slightly greater than single lane, it is 5.5 meters. And at last, multi-lane pavements, when the number of lanes are more than one, and each lane will be of 3.5 meter width. These are about different width of carriageway recommendations and as per Indian Road Congress.